of spades, right? Actually, there's two. The ace of spades and the ace of clubs. They're both black and red, black and aces. So if I don't take those out, I'm going to count them twice, am I not? Because I'm going to count them here and here. So I've got to subtract it so I don't count them twice. Do you see? I'm going to take out the ones that are aces and black. Does that make sense? Just so I don't count them twice. So which ones, what's the probability that they are aces?
4 over 52.
4 out of 52. Plus, sorry.
23.
Because it's union, right?
23.
That they are black.
26.
26 out of 52. But I've got to subtract the two that are both black and an ace. Minus 2 out of 52. And that's it. You do those and you find the result.
That's it?
Yes?
Why 2?
Because how many are both ace and black? The ace of clubs and the ace of spades. And since you already counted them here, if I don't subtract them, I'm going to count them twice. And my probability is not going to be correct.
But the 4.
Huh?
Isn't there more than 4 aces? No, right?
That are black. Oh, there's more than 4 aces. She's correct.
No.
There's one ace per symbol.
There's one per.
There's one per thing, yes.
Oh, okay.
She's confusing me. Yes, there's a red, there's one of each. And one of each means you already counted these. And if you counted them black, you're going to count them again. So you've got to take those out so you don't count them twice.
But why don't you just don't count them?
Huh?
Why don't you just don't count them twice? Like you just do 2.
That's why I subtract them.
But can't
To not count them
You
twice.
can't just do 2 or 52 directly.
Yes, you can. But that's going to be in your head. To not count them twice. Just make sure you don't count them twice. Whether you do it at the beginning or at the end is up to you. This is like infallible, because you're taking away the ones that you don't want to count twice. But if in your head you can count without them from the beginning, sure, it's the same exact result. Okay? We good?
Yeah.
That's it? Do you need another one, or is it kind of clear?
I think it's good.
Okay, and the notations for permutations and combinations I already gave you, but I'm going to remind you just in case.
And should I learn that one?
92.
Just, let me just give you the general formula if you want to have it in your notes for the test or something. The probability of A union B is the probability of A plus the probability of B minus the probability of A intersection B. Okay, if that helps at all. No, might help. And you have to remember that OR is union and is intersection. And union is always a plus. Okay, got it?
And intersection is what?
Intersection. It can't be done like that. Intersection is, do you understand what intersection is? If, for example, if you have, let's say you have numbers here. You have 1, 2, 3, 4, and 6. And you have another set, this is A, and this is B. And you have a set that is 1, 2, 5, 7, and 8. If I ask you what the intersection between these two is, what would you say? You have to put them together. And which numbers are in both of them? 1 and 2. See? I put them in this would be the intersection. This is A intersection B. Because because they're in both. This one, you still have the 3 and the 4 and the 6. And this one, you have the 5, the 7, and the 8. But if you notice, in the intersection of those two sets, you only have the 1 and the 2, because those are the ones that are in both of them. But if I have A union B, it would be 1, 2, 3, 4, 5, 6, 7, and 8. Because it's the union of everything. And the 1 and the 2, which are in both of them, I only place once. So it's the union of both sets. Is it clear? Okay. May I erase? Okay, so now, just really, really quickly, I'm gonna put, this one, Saxon uses one specific type of notation. There's a bunch of them, okay? And I will try to give you some of them, not all of them, because I don't know all of them. But this is permutation. Do you remember the difference between permutation and combination? No? Combination is everything, every possible pattern that you can get, whereas permutation is a combination with restrictions or in a specific order. Remember this? And where n, total number of things, and r is things taken at a time. Remember this? And you can have, you can find this in books. It could be either like this. I've also seen it like this. I've also seen it like this. There's only this. There's P and R. That's mostly how you see them in books. And they all mean exactly the same thing. Okay? We good? Mm-hmm. Obviously, with combination, you change the P for a C for the second thing. Do you want us to do one of these, or do you remember how to do these? You want one? Do you remember?
Can we do it?
Yes, we can do one. So it says, example 92.3. It says, take the permutations and combinations of 7 things taken 3 at a time. So N is 7, R is 3. And you just go ahead and do P, 7, 3, and this would be 7 minus 3. Tutorial, that would be the number of permutations that you can do. And the number of combinations would be 7, 3. Easy, right?
So now we're supposed to do both.
If it asks you for both, you do both. If it just asks you for one, you do one, right?
Question.